Hello guys. In this video we will review Spring Boot application performance. We will look at specific cases where and how to use scheduler and what kind of problems we can expect, what the behavior of schedule, how to deal with threads and such. This video is more like a walkthrough. You can follow with me, and in the end of this video you will build some practical knowledge of how to use Spring Boot application with schedulers and how it works with threads and what to expect. Like in my case, I'm analyzing the performance of existing applications and just looking how all this works from the practice, not just from documentation. I mean, it's nice to have a documentation, but sometimes it's just nice to go through and see how it works for yourself, how it makes sense. Okay, enjoy. Let's imagine that you have an application that use scheduler, right? And it has some demo schedule, which is the component. So, and this demo scheduler has a method that like a fetch data, let's say, or let's say fetch one, right? And it's like a scheduled. And let's say fixed delay 1 second. So every time when we run this application, we'll try to fetch some data, let's say from some other service, what it's doing. Let's say it's updating cache. There are certain scenarios to take into account. So in this specific case, what's going to happen if updating cache taking 2 seconds to execute, or even 20 seconds to execute, right? What is the default scheduler for scheduler? So let's go and figure this out, this scenario. What's going to happen if our task, whatever we put here, we'll call a task, taking some time to execute, okay? This period of time is bigger than the fixed delay itself. It's running it with fixed delay, one second. So to do, figure out what executor in use for the scheduled task. And another thing to do, create a 20 seconds task here. Let's print a name, the name of the thread. Okay. Also, we want to see like a time in seconds. Well, this time will be like from the beginning of times plus every second. Okay. So divide by 1000 because it's milliseconds. 1000 is going to be seconds. So it will help us to print this stuff. So let's print it here. Bam. Seconds. Let's run this application again. Okay, so we see this scheduler in 1 and the second. So every second, you see 5, 6, 7, 8, it runs this task, which is kind of cool. And this to do, we have to make this task to be run for 20 seconds. It's like that, old school, right? New, not run, start, of course. And the name is our task. Let's say 20 seconds task. Then we can do this public void run. Then we can define, so we will move this inside. We will make it run for 20 seconds. Thread sleep. Let's put it like here to be nice. So here we go. We have this task. So the question is, what's going to happen if we run this? This task takes 20 seconds to run, and this method will be run every second. So before running, let's just assume this fetch will be run every second. So second one, it will run this fetch. This in turn will run a new thread that will take 20 seconds, and it's gonna be running, right? Then next second, this scheduler will run this method, right? and it's gonna take 20 seconds to run. Yeah, this is what I think gonna happen. But okay, you know what? Because this is taking 20 seconds, like why should I run this fetch again? I have to wait until this is done, right? Because by some reason we don't want to run this fetch again and again. But if we do, if if everything is happening like that, then we're gonna end up having many threads running in background. Okay, in this case we run the thread, we create the thread again and again and again with this new thread, and over time we're gonna have like, I don't know, theoretically like many millions, could it be many millions of threads that are running there, because this is like 1 second and this is 2 seconds, and theoretically this 20 seconds could be not 20 seconds but let's say 2 minutes by some reason, right? And then we for sure will end up with run out of thread exhaustion or something like that gonna happen. Let's run this right now. Before doing this, we'll repeat this process here just because we want to see what's going on in this thread. So we will print one thread and another thread. This is not the task thread name, but fetch thread name. Okay, just to name it correctly. And we don't need to do sleep actually here. We'll just print it. Okay, let's do it again. Yeah, like I expected actually. Let's see what's happening here. On first second, there is schedule 1. Then it runs at the same second. It runs 20 seconds task. Next second, again scheduler 1, and it runs another task in the same second. You see, the pattern repeats. It's running this again and again and again. If we use some tool to monitor how many threads we have, that's by the way a good idea to do, we will see that the number of threads, task threads, are growing. You can easily imagine that this is what is happening, but we will double check it anyway. Let me go and share my desktop. So that's what we have here. I just ran visualvm. This is the tool. If you never use it, just go and install it. This is the tool to monitor threads on your local machine or remotely. And that's what we're going to do right now. So this is how it works. Let me just go through it. In our case, it's not remote. It's IntelliJ IDEA. You see, it's see the IntelliJ IDEA. It also see our application, this performance application that run with this PID 5 something 35, and this is exactly what we are interested in. Let me go there. Okay, so right now our application is running. This is our threads. You see how many threads we have right now? 20 seconds. 1, 2, 3, 4, 5, 6 seconds, 7, 8, 9, 10. So right now we have a 10 more and more. So you see it generates new threads again and again. But the scheduling 1 is just a single thread. That's a scheduling 1. Yeah, you see there are many of them. And this task, once it's done, it just disappeared. That's what's gonna happen in your application if you do this kind of scenario. Let's go and change something in the application. Let's do it maybe 60 seconds, right? Let's do it again. Because we rerun the application, this one is lost and the new one pops up. So we click on the new one and go into the threads. We see our scheduling 1 and then this 20 seconds task. Right now it's not 20 anymore, it's a 60 seconds task. Actually, we should rename it. There will be more and more of them because it's taking right now more time to execute this task. So that's how many of them we already have. So at some point, if we have many threads, it might be not good for us, right? Because depending on what these threads are doing, we might face some issues. One can say, but another can say that it's kind of okay to have many threads. I mean, I have a machine that's able to handle millions of threads, then why not? And you will be right also. Right now, as you know, in beginning from Java 14, there is so-called virtual threads. JVM managed, and it can handle like many threads, much more than the way it was implemented before, when threads were used on operating system level. That's basically what it is. So theoretically, if we use that threads, that will be virtual, then it will be kind of okay to have many threads here, and the performance-wise, will be fine. But what is important to understand, though, is you have to understand that this is how it works, right? Once schedule is started, it will start another one and start another one, another one. But what if we don't want to do this? What if we want to implement such a logic that when we run something with delay 1 second, and if this task takes more than 1 second, then the scheduler not supposed to run new task again. Until current task is done, then we run another task, right? That might make sense because you cannot predict like how much time it will take. Maybe there is a timeout with the server, or maybe server taking more time to execute something. So whatever we call, let's say we call radius cache here in this 20 seconds, right? And then we don't want to create new threads again and again that trying to do something. We just want to let that one thing to be finished, and when it's done, then we will run another one in 1 second. That's what we want to do. Let's try to do it. I'll just copy paste all this and put it there, and it will be fetch 2, and I'll comment this for now. And instead of fixed delay, we'll try to use something else. So it's like a fixed delay, a fixed rate, right? Fixed rate 1. Let's do it again. So this application is done, and we'll switch into a new one, threads, 20 seconds. So what's going on right now? You know, the threads are still growing, 55, 56, 55, 58, 59, 60, etc. So it's still growing. I would say nothing has changed. So let's go and investigate how we can do this. So we tried fixed rate, we tried fixed delay, but what we should do is probably to read documentation, right? Okay, that's it for first video, and we will go with the next steps in second video. We will answer all our questions that we have so far. Okay, thanks.